Hello, everyone. Thank you for your patience while I'm gone. I hope to be back by Thursday. Today, we're going to be going over the scientific destiny exam that you took last week. I know it's been a few days since you've taken that, but today we're going to go over that and then make sure that you understand the test and what was on it, how well you did, what you did right, what you did wrong, and today you should be able to begin the reassessment process. I'm going to share my screen. Okay. So hopefully by now, everybody in the room has taken the exam. If you have not, then you need to get the required materials, which would be a copy of the test questions, reference page, a calculator, and you need to head down to the testing center right now. They should expect you, and they have Chromebooks for you to take the test. You find the announcement on Canvas that says Scientific Destiny Exam, and you get started. So if you haven't taken the test, you need to go do that now. The sub can pause the video if they need to. Everyone else, you have already taken the exam, so you should have a Chromebook. You should have your old study guide, which can be located in the bins in the back of the room by the bookshelf. And you also need a reassessment ticket, and those can be located at the back of the room by the lab door. Make sure you grab the reassessment ticket for this class, Physics A, not the Physics B, and it says at the top which is which. So if you have not done that yet, again, the sub can pause the video while you have some time to do that. You need to log into GradeCam so you can see your answers while we go over the test. So if you haven't done any of those things yet, I will kind of pause for just a second, let the sub pause the video, and go ahead and do those things. So I'm assuming you have all these required materials now: Chromebook, old study guide, reassessment ticket, and you are logged into GradeCam so that you can see your answers while we go over the test. Remember, the first part of the reassessment ticket you can do right now, and that's just to have you completed the study guide, yes or no, and if you have not, fill in which pages you need to complete. As we move, we're moving a little bit further into the course now, and so my tolerance level for complete versus incomplete is kind of shifting towards the less tolerant side. So if I see problems that are not done, I tend to not give you as much leeway on that anymore. So that's the most common reason people have incomplete study guides is a problems, practice problems that weren't done. If you have an activity that you missed because you were absent or for whatever reason, and you can't really just fill that in, you can talk with a partner and talk to them and see how it went, get the data, fill in the graphs, do that sort of thing if you would like, or you can sign up for Flex and come see me and we can get that done. Again, I hope to be back by Thursday. So let me give you a quick rundown of how we did as classes. So this is the second hour data. I hope you can see everything here. Really high average, 76%. Most of us got A's. Second most was B's. 4 of us did not get an A or a B. So again, my goal for every exam and summative assessment we do in here is that everybody has an A or a B after the reassessment process. So I'm hoping in second hour, there are 4 of you that sign up. Plus, if you have a B and you want to get an A, there's no reason you can't sign up. You just got to make sure the study guide's done first. Okay, here is third hours, okay, a little bit lower of an average. And here is fifth hours. It's interesting, the averages went down as the day progressed. I feel like my teaching tends to get better as the day progresses. I don't really do that on purpose, but it's just for third hour, I've already taught the class once, and for fifth hour, I've already taught the class twice. So it's just kind of interesting how that worked. We'll talk on Thursday. Maybe we need to do some seating adjustments or what have you, but we'll talk then. All right, so let's start going over this test. A couple things that I wanted to talk about right now because I tried my best to provide repetitious instructions on these things prior to this test, but I think some of you still either misinterpreted my instructions or maybe didn't quite follow them as much as I'd hoped. So a couple things. One, this is the little segment from your reference page that really was pertinent to this test. There's a whole bunch of other quantities and equations that did not matter for this test. But remember, the quantities over here on the far left, these are measurable things: mass, volume, density. Their symbol is listed here in the second column. Their formula is listed here. Okay, I know it says there's no formula for mass, but remember, we can derive a formula based on this density equation, and you had to do that a couple times. Regardless, this last column over here is the unit. So we'll come back to that in a minute. Right over here, this is also on your reference page. It's the steps that I think really help when you have a calculator-based problem. When you have information that is given to you in the form of measurements and you are asked to solve for an unknown. I always think it's helpful to go through these steps. And if you don't think you need to and you're doing fine, then I'm not going to make you do it. But if you find yourself struggling to do these types of problems, I really suggest following these steps. So it's got a nice little acronym that you can go by, but essentially you want to figure out what the problem gives to you, what the problem is asking you to find, the unknown. You want to pick a useful equation. That's what the I means, identify. And sometimes that means picking a useful equation and having to do a little bit of algebra so that you isolate the variable you're actually trying to find. And then once you have that, you simply do the math. Plug in the numbers to your calculator and write down the answer that comes out. The last step says evaluate. It says to make sure that your answer is reasonable. It has the right number of decimal places, the units are correct, that sort of thing. And so last thing I'll talk about right over here, this is in the bottom right corner of your reference page. And this is how I would like you to answer any problem that is a calculator problem. It has an A, a B, and a C. I do this for a few reasons. One, I think it helps to make sure that you are conscious about things like decimal places and units, because a lot of times we don't write those things down when they are very, very important. I also break it apart like this to avoid rounding errors. Sometimes people round up, sometimes people round down. I think different people have been taught different rules when it comes to rounding, and I don't want to really deal with those rules. I don't think they're super important. I think it's much more important to be conscious of decimal places and SI units. And lastly, I break it apart like this because if you'll notice, the only portion of a calculator problem, an ABC, that actually is dependent on you doing the correct math is part A, the whole number value. That part is dependent on you either dividing the right numbers, multiplying, adding, subtracting, whatever. That's the only part. Part B doesn't depend on you doing the right math. Part B is the information to get part B correct is found in the context of the problem. You don't even need to do the math to get part B right. You just need to know the number of decimal places, which we know our guideline is we are as accurate as the least accurate measurement we were given. Same with part C. Part C is simply matching the correct SI unit to the quantity that you were trying to calculate for in the problem. No math required. It's just looking at the reference page. So if it's a mass that you're solving for, you need to put kilogram or sometimes gram. If it's volume, you need to put liter or sometimes milliliter. And if it's density, you need to put grams per cubic centimeter or grams per milliliter. So if you encounter a calculator problem, 1 out of the 3 possible points is dependent on you knowing how it and doing the correct math. The other 2 points are old skills we've already learned. So that's essentially 2 out of 3 points that are just kind of gimme points, right? So there's no reason to get those wrong. So as we go through the test, and if you're getting parts B and C wrong consistently, make sure you understand why. Because in the future, I don't want you to keep missing easy points like that. Okay, so let's begin. I want to point this out at the top of the test. It says, please note some units have been intentionally removed from items. Assume the quantity represents the established SI unit for the given value. So I remove units from numbers sometimes because I'm trying to not give away the answer. I'm asking you to assume that whenever I put units, I am using the established SI unit: kilograms, liters, grams per cubic centimeter, grams per milliliter, seconds, meters, etc. Not a big, but a common misanswer for part C, when I asked for what the unit was, some of you put the word units, UNITS. That is never going to be the correct answer. I omitted the unit in the problem on purpose. I'm asking you to assume that I'm using the established SI unit. So let's go through number 1 and you'll kind of get the idea. Number 1 says, if the density of a diamond is 3.50 units, in the context of this problem, I am to assume that I'm using the established SI unit, which we talked about in class, but it's also on your reference page, is grams per milliliter, grams per cubic centimeter, or it could be kilograms per liter. Okay? I'm assuming those are the units being used. And it says, what would be the mass of a diamond whose volume is 0.5 units? Again, I'm going to assume that the volume units being used here are the established SI units, either liters or milliliters. And so at that point, we can go through the steps. The first step is to identify what was given to us in the problem. It is clear that the density is listed right here is 3.50. The volume is also listed as 0.5. So I'll be writing these down. Hopefully you use scratch paper or some form to keep track of this information. But I would write down those 2 bits of information. That is all the information I'm given in the problem. Then I would identify what is the problem asking. What is the unknown variable? And the problem says, what would be the mass? And so that is the unknown variable. That's what I'm trying to now find. And so the third step is to identify a useful equation. In this context, I'm fairly certain the useful equation is going to be density equals mass divided by volume. But as this equation is written, it is not useful because I already know the density. I'm trying to find mass. So I need to do a little bit of algebra to isolate mass. When I do that, I will get mass equals density multiplied by volume. At that point, it becomes very simple. I plug in the numbers, I do the multiplication, and my calculator gives me this number, 1.75. Okay? Rarely, if ever, is this going to be the number that I plug in. In fact, I think it's safe to say never. This is never going to be the number that I will plug into 1, A, B, or C. So let's talk about how we want to split this apart. Remember, part A wants the whole number part of your answer. Whole number refers to anything left of the decimal, which in this case is 1. So that should be your answer for 1A, 1. 1B asks for the number of decimal places, not the value of the decimal itself. Our guideline states that we can only be as accurate as the least accurate measurement that was given to us. In the problem, there are 2 measurements given. One of the measurements has 2 decimal places, and the other only has 1. This measurement here with 1 decimal place is the least accurate measurement given to me. And so that is going to place the limitation on how accurate my answer can be. 1 is the least number of decimal places that was given to me in the problem, so I can only have 1 decimal place in my answer. So that is my answer for 1B, 1. I'm not going to put 0.7 or 0.8. I'm just going to put 1 because I don't really care about our rounding. Lastly, part C asks for what is the SI unit. Again, units, meaning UNITS, is never going to be the correct answer. This is a problem that is asking for mass. And so we have to choose a mass unit. Because both numbers in the problem didn't really specify whether we were looking at a larger object, which are typically measured in kilograms, or a smaller object, which are typically measured in grams, either one of those answers would be correct on this one. So you could have selected grams or you could have selected kilograms. Just a side note, when you're putting in units, use the shortened version, G or kg. You don't have to write out the whole word. All right, let's move on to number 2. Number 2 says an ice cube measuring 5.800 centimeters by 5.800 centimeters by 5.800 centimeters. So we're thinking about a cube where each side length is 5.8 centimeters. Has a mass of about 178.910 units. Again, the units here is omitted intentionally. I am to assume that I'm using the established SI unit. We'll talk about what that is in just a second. What is the density of the ice cube? Well, again, I want to write down everything I know. The problem tells me the side lengths of each dimension of the cube plus the mass. The problem would like me to find density, and I know that density is mass divided by volume. So I would put the mass on the top, but the context of the problem does not tell me the volume. But I think most of you figured out you could calculate what the volume is. We know that volume of any cube or rectangular shape can be found by multiplying the dimensions, the side lengths. So if I multiply these 3 sides, I would get the volume, which I've done over here. So here I have the mass, and here I have the volume. And so finally, I should be able to find density. I should be able to do mass divided by volume. So I plug that into my calculator, and this ugly looking number is what is given to me, 0.91696,051. I'm assuming the decimal places keep on going. So how do I include this in the answer like you should? Part A, what is the whole number? Anything left of the decimal? Well, that's 0. Sometimes the calculator says 0, and so you put 0, and sometimes it just says 0.9, blah, blah, blah. So I'm okay if you put none as the whole number. Either one's fine with me. Part B, how many, the number of decimal places are you allowed in this problem? Well, if I go back to the problem number 2, each measurement in the problem has 3 decimal places. So that is the limiting number I can have. So now again, 3 should be your answer for part B, the number 3. I don't want to put 0.916 or 0.917. That's not how I would like you to answer this. I want you to write the number 3. And finally, part C. The question becomes, are we talking about kilograms for our mass unit or grams? Well, we mentioned in class that if an object is small enough to be measured by cubic centimeters or milliliters as its volume, it's also small enough to be measured in grams for its mass. So since cubic centimeter is my volume unit, I'm going to assume that the mass unit was measured in grams, and so that makes my density unit grams per cubic centimeter or grams per milliliter, because those are the same thing. So that should be your answer for 2C. Number 3. Number 3 says a bottle of liquid has a density of 2.1 units and a mass of 7 units. What is the volume of the bottle of liquid? Same step-by-step process. The problem tells me the density. It also tells me the mass. The problem is asking for the volume. So given that information, I know that density is mass divided by volume. So I do have to do a tiny bit of algebra. I find that volume is going to be equal to mass divided by density. Okay, very commonly missed problem when I graded your test. A lot of us did mass multiplied by density. It's mass divided by density. So 7 divided by 2.1, this is what my calculator tells me, 3.333, and the 3's go on forever. We've talked about before, repeating decimals are never, we can't use those as measurements. So we definitely don't want to put them in our answer. We don't want to include too many. So for 3A, the whole number is 3. For 3B, I have to look at the problem again. This measurement has 1 decimal place. This measurement has none. That is the least number of decimal places. So that is the limiting factor for me. So I can have 0 or no decimal places. I'm not trying to say that the value of the decimal is 0. I'm saying I can't have any. So I put 0 or none. And finally, 3C, what are the units? Again, this is volume that's being asked for. So this established SI unit is liters, but I also think it's acceptable for you to put milliliters since both measurements, I omitted them and it just says units. Okay. Number 4, an irregularly shaped stone was lowered into a graduated cylinder with an initial volume of water equal to 2.0 milliliters. The height of the water rose to 7.0 milliliters when the stone was placed in the graduated cylinder. So hopefully you all, this should be ringing a bell. You've all done this. You've all measured volume of irregularly shaped objects by placing them into graduated cylinders. And so quick math in my head, the volume of this stone must be 7 minus 2, which is 5. So 5.0 milliliters is the volume of the stone. Problem also tells me the mass of the stone is 25.00 grams. It asks for the density. So I think I'm well on my way. Volume 5, mass 25. What is the density? Density is mass divided by volume. 25 divided by 5 is 5. So to answer it correctly, 4A, whole number is 5. 4B, how many decimal places? This measurement has 1, this measurement has 2, so I can only have the lower of the 2 measurements, which was 1 decimal place. So I'll put 1 as my answer for 4B. For C, what are the units? Density units in this case are going to be grams divided by milliliters, so grams per milliliter, or you could have put grams per cubic centimeter because they are equivalent. Okay. If you want to pause for a second, you can, but I'm going to keep going. Number 5. Number 5 says, you are given the opportunity to buy a gold-colored cube for $1,000. The seller is claiming it is gold. It's gold nugget. Gold has a density of 19.3 units. It's a lot. Gold atoms are quite large and jam into a very small amount of space. You measure the cube to have a volume of 8.0 cubic centimeters and has a mass of 40.00 grams. It says to calculate the density of the cube you have been offered to purchase to determine if you have been given the bargain of the century, considering the price of gold is currently about 55.00 grams or dollars per gram. just a quick side note, that is an accurate number. That's about the current price of gold. So if you do the math, 55 times 40, that is quite a bit of money for that sample of gold. That comes out to be about $2,200. And this person's trying to sell it to you for only 1,000. That's less than half the price. So you don't want to be fooled, right? You want to know, is this really gold? And so we can follow the parameters of the problem and calculate this thing's density. We know the sample's mass is 40 grams and its volume is 8. We know that density is mass divided by volume. 40 divided by 8 gives us 5. So the density of this nugget that is claiming to be gold is 5 units. And so to answer the number 5 correctly, we'll get into if it's gold or not in just a second. But to answer the question for 5 correctly, 5A would be 5. 5B, how many decimal places? Again, this measurement here for volume had 1 decimal place. This mass measurement had 2. So 1 is the lowest amount of decimal places I can have. So I'll write number 1 for 5B. And 5C should be grams per cubic centimeter or grams per milliliter. Okay, so number 6, is the gold colored cube from item 5 above actually gold? Clearly it is not. Clearly it is not. So the correct answer for 6 is N. All right, number 7. Explain the phenomenon of the stacked layers of liquid and objects seen in the container pictured to the right. So we have a series of different liquids: oil, alcohol, different kind of oil, water, dish soap. We have some objects as well: cherry tomato beads, soda cap, ping pong ball, and they are separated into layers rather than mixing. You have ample experience with this by now. Most of you answered this question fairly well. This question is graded out of 4 points. Clearly, I think the reason they don't mix and rather separate is because they all have different densities. And so if you mentioned the word density or dense in your explanation for number 7, I gave you 2 out of 4. Hopefully you explained more, but if that's all you said was they have different densities and that's why they don't mix, then I gave you 2 out of 4. To get the full 4 out of 4, again, I wanted you to really flesh out and explain what you think about this setup. And so from what we've learned in class, we know that objects that sink are more dense than anything above them, and objects that float are less dense than anything beneath them. And so to give you the full credit, 4 out of 4 in this question, if you had some way of telling me that more dense things sink, less dense things float, I gave you full credit. So maybe you told me the order of densities. Maybe you said in order from greatest to least density is dish soap, cherry tomato, water, oil, blah, blah, blah. That would have been great. Or maybe you said the ping pong ball is at the very top because it is the least dense of anything in this setup. Again, full credit there. I was just looking for some mention that more dense things sink and less dense things float. Hopefully that makes sense. Let's move on now to number 8. 8 through 11 are dealing with this setup, which hopefully looks familiar to everybody. Our little density bottle setup. It says the image shows a progression of time from left to right, meaning H happened after R, W happened after A, and so on. And so let's just get right into it. Number 8 says, if the density of the beads were equal to each other. So this is slightly different setup than what we're used to, because clearly in the setup that we did, which this is a picture of, the density of the beads were not equal to each other. They were different. These beads, the clear or white beads, whichever ones you had, were less dense than these blue and green or color beads that sank to the bottom. But I'm saying I'm asking you to imagine for a minute that the beads have equal densities to each other. So imagine that for a minute. I'm also saying that the beads still have less density than the salt water. And remember, the salt water is at the bottom. It was the most dense in the bottle. I'm asking, how would the beads now look in phase A after the bottle is shaken? Well, let's think about this for a minute. I'm going to look at phase R just for a second to remind myself that both beads, the white, clear ones, and the color beads, had a density less than salt water. That's why they're on top of it. But they had different densities than each other, which is why they separated, right? When we shake the bottle, we temporarily mix the alcohol that's on top with the salt water that's on bottom. And it temporarily makes some kind of new hybrid liquid density, of which the white clear beads have a lower density, so they float on top of it only for a moment. And the color beads have a higher density than that mixture of liquid, and so they sink beneath it. But if both beads had identical densities, then that would eliminate this separation of the beads. I hope everybody can see that. No matter where the beads went in the bottle, they would stay together because they had the same density. So the question becomes, well, where would they go? Would they go to the top? Would they go to the bottom? Would they stay in the middle? Well, again, we remember that both beads had a density less than salt water and more than alcohol. So the question becomes, could they all rise to the top? And I think the answer is yes, they could. They all could have risen to the top. Could they all have risen to the bottom? Yes, they also could. It just depends on what their actual specific density was. Could they have remained in the middle? I think definitively the answer is no. They could not have remained in the middle or remained spread out. They would either all be at the top and then they would all sink back down to the middle, or they would all have sunk to the bottom and then slowly risen back to the middle again. So that is, I think, how you could get full credit for number 8, explaining that they were going to be in the same place because they can't separate anymore because they have the same density. The two possible options are they would either all be at the top or all be at the bottom. Number 9. Number 9 says, which image or images shows beads fully floating in alcohol, which is less dense than water? So we have to think about this for a second. Fully floating in alcohol, meaning beads that are completely on top of alcohol. Well, let's go through. If I look at R, clearly it's not R. All the alcohol is at the top of the bottle and all the beads are underneath it. So R can't be it. H, I have a mixture of liquids with the beads scattered throughout the liquid. I don't think I can confidently say H is an answer either. A, I have white beads on the top of the bottle, the very top. There is no liquid above these beads at this point. All of the liquid, including the alcohol, is beneath them. So 9, A is a correct answer. A shows beads fully floating in alcohol. Not permanently, but for at this moment in time, it does. If I look at W, it's showing that beads are beginning to sink. And I ask myself, well, why are they sinking? Well, they're sinking because the alcohol and the salt water are separating themselves. So what is this liquid that is starting to get above these beads? Well, it's alcohol. And so these beads are no longer fully floating in alcohol. They're starting to sink. Same goes for K, same goes for S. So for number 9, the only correct answer is A. I hope that makes sense. Number 10 says, which images show beads fully floating in salt water? Okay, so if I look at R, again, I remember salt water is the more dense of the two liquids, so it is currently in the bottom of the bottle. Here are all the beads on top of all of the salt water. So yes, R is a correct answer. With H, I don't think I can clearly say that is an answer because all the beads are mixed up in here and they're not really floating or sinking in anything. With A, I have to remember that I still have a pretty good mixture of liquids, but I do have beads at the very top of the bottle. All of these white beads are on top of all of the liquid, which includes salt water. And so yes, A does show beads floating on top of salt water. W also does, because remember, as these beads start sinking, they are not sinking into salt water. They are only sinking into alcohol. So this liquid up here is alcohol. This liquid down here is salt water. This liquid in here is still a mixture of the two. But these beads are still floating completely on top of alcohol. Same with K, same with S. And so number 10, to get full credit for every correct answer, you would put R, A, W, K, and S, not H. So for number 10, the way I graded it was you got +1 or 1 point for every correct answer and a -1 for every incorrect answer. If you think there might be an error in how I graded number 10, please let me know. You can email me or tell me on Thursday. Last question for this section, number 11 says, provide the text which would accompany an explanation of the model in phase R or S. Everybody did this. Everybody had an opportunity to explain this model as completely as possible in their study guide. So really, you just had to kind of transfer that here. To get full credit for R and S, I hoped that you would mention density, that there are different beads and different liquids in this bottle that had different densities. The most important aspect, I think, is the beads sit in the middle because they have a density that is in between the two liquids. They are less dense than the salt water and more dense than the alcohol. And so an explanation along those lines would get you full credit. If you just mentioned density, I took some points off. If you had maybe some things mixed up, maybe you said something like, maybe you had it mixed up and you said that the beads were less dense than alcohol and more dense than salt water, that would take some points off as well. So if you have problems with the way I graded number 11 and you think you deserve more points, please let me know. All right, the next section says for questions 12 through 24, select from the graph options below to represent the relationship. So if we remember, H is depicting a relationship where if I increase the independent variable on the x-axis, the dependent variable does not change. That we would call that a constant relationship. Graph A is showing that if I increase the independent variable, the dependent variable changes, but not in any predictable manner. And I would label this as no relationship. Graph W is showing that as I increase the independent variable, the dependent variable also increases. We call that a positive or direct relationship. Finally, graph K is showing that as I increase the independent variable, the dependent variable decreases. And we call this a negative or an inverse relationship. So I simply want you to identify which one it is. Number 12, volume and density. We know that as volume gets bigger, the density of the object must get smaller. And so that would be K, a negative relationship. Number 13 is mass and density. As the mass of an object gets larger, the density also gets larger, assuming the volume stays the same. And so number 13 is W. Number 14, IV or independent variable increases, DV or dependent variable decreases. Well, that's the definition of a negative relationship, so that's K. Number 15, positive, that's W. Number 16, negative, that's K. Number 17, more time studying led to increased proficiency. As I think about that one, time studying feels like the independent variable. It's the variable that I am responsible for manipulating. And proficiency would be the variable that responds to that. So that'd be the dependent. So increasing one thing led to an increase in another thing. That is a positive relationship, so that would be W. Number 18, spending hours playing a game without any increase in level. Increasing the time spent playing a game, that would be the independent, led to no increase in level, that would be the dependent. That looks a lot like H, a constant relationship. Number 19, circumference and diameter. We know that as the diameter of a circle gets larger, the circumference of the circle also gets larger. And so that would be a positive relationship, W. Number 20, density of an assortment of objects not made of the same material. This graph would look similar to the graph we made in our study guides on page 9. If I have an assortment of objects, there's no guarantee their densities are going to be the same. In fact, it's pretty likely that their densities will be scattered all over the place. And so this is going to be A, no relationship. Number 21, X value increases, Y value decreases. That is the definition of a negative relationship, so that would be K. 22, increase in amount of water and density. So as I think about this, it's saying that as I pour more water into a container, what happens to the density of that water? It doesn't change. Water is water as long as it remains in its current state of matter, whether liquid or solid. But if I add water, it's going to take up the same amount of space per unit of mass. Or maybe I should phrase that, it will have the same mass per unit of volume. And so the density will not change. And so that graph would look like H. Number 23, number of hours worked and amount of paycheck. Hopefully, hopefully that is a positive relationship, W. The more you work, the more money you earn. Finally, 24, length of pencil versus usage. Well, if I think about typical wooden pencils, which I was hoping that was the idea you were getting, but I think you could still make the argument for a graphite pencil. The more I use the pencil, the shorter the pencil gets. And that is a negative relationship. So the length of the pencil, or sorry, I should say, as the usage of the pencil increases, the length of the pencil decreases, and that is a negative relationship, K. Okay, the last few problems are on identifying variables, and I have one question about a title. I think most of us did well in this section. There were a few of us that just got everything mixed up. So for whatever reason in our minds, we had what the independent and dependent variables are just mixed up. So I want to do a quick refresher on that. Remember, the independent variable is the variable that is manipulated, that we change as the person responsible for the investigation. The dependent variable, we don't actually change on its own, but we are observing how it responds to a change in the independent variable. So it could change, it also might not, just depends on the investigation. We don't know what's going to happen, but it's the thing that we measure and observe as response. Hopefully you remember the acronym DRYMIX, D-R-Y-M-I-X. So I'll read this first section. It says Clark heard adding salt to water made it boil faster. I don't know if any in the room have taken a chemistry class yet, or maybe you just already know this, but it turns out that that statement is actually false. When you add salt to water, it actually makes it boil slower. It raises the boiling temperature of water, but you didn't need to know that. This says, being a scientist and aspiring cook, Clark decided to conduct an experiment to test this. Clark used 500.0 milliliter samples of tap water with 10.0 grams of salt added, tap water with 20.0 grams of salt added, and samples of tap water without salt added. Clark did triplicate trials of each treatment without changing the gas burner, gas setting, or pot. Clark timed how long it took each pot of water to boil and the density of spoons used to stir the liquid. Number 25, what is the independent variable? Again, this is the variable that we are manipulating, we are changing. So right away, I can rule out quite a bit of these variables because there are a lot of things in here that Clark didn't change. For example, Clark used tap water in every different trial. So tap water can't be the independent variable. It says that he didn't change the gas burner, the gas setting, or the pot. So those can't be the independent variable either. The thing that Clark changed, manipulated, was the amount of salt that he dissolved in the water. And so that should be your independent variable, the amount of salt. So I think I graded 25 out of 2 points. If you put salt or amount of salt or different types of salt water, I gave you 2 out of 2. If you just put water or type of water, I think I gave you 1 out of 2. And if you put anything else, I gave you 0 out of 2. Number 26, what is the dependent variable? This is the thing that Clark is measuring and observing how it responds to him changing the amount of salt. And if I read again, Clark timed how long it took each pot of water to boil. That is my dependent variable, the time it took for the water to boil. So some of us put boiling water or water boiling. Again, we want our dependent variable to be some kind of measurable quantity. In this case, it's time. So to get full credit for 26, I hope to put time to boil, or time to get the water to boil, or how long it took to boil, or I think I was even okay with speed or how quickly it boiled. I think those all communicate the same thing. Number 27, finally, what would the title of Clark's graph be? This was probably the most commonly missed question on this kind of section of the test. I think we kind of forgot how to title a graph. Remember, this is on page 4 of your study guides if you want to look it up real fast. We title graphs according to the following guideline: dependent versus independent, or Y versus X. So in this case, I should have graphed this as the dependent variable, which would be time to boil, versus the independent, which was salt added. So that would be an acceptable title. So for 27, if you had both variables in your title in the correct order, dependent versus independent, I gave you full 2 out of 2 points. If you had both variables present in your title but in the wrong order, so maybe you said salt added versus time to boil, I gave you 1 out of 2. And then if you had a title that had incorrect variables in it, I didn't give you any points. Okay, last section, or last few questions here. Just says to provide the most appropriate response, very similar to the ones above. It says the amount of pollution produced by cars was measured for cars using gasoline containing different amounts of lead. So number 28, what is the independent variable? What is the thing being changed? It's not the pollution. The pollution might change, but it doesn't say that they are physically changing the pollution. They're just measuring it. What they're changing is the amount of lead in gasoline. So that is the independent variable. So for 28, you had to put the amount of lead, not the gasoline, the amount of lead. That's full credit for 28. And 29, the dependent variable, what is hopefully going to respond to a change in the amount of lead in gasoline? That would be the amount of pollution. Last 2, a study was done to find if different tire treads affect the braking distance of a car. What is the independent variable? What is being manipulated? Well, that would be the tire treads. 31, what is the dependent variable? What is responding to a change in the tire treads? That would be the braking distance of a car. And that is it. That is the end of the test. Okay, so hopefully by now you have kept track and you know exactly how many points you missed in each section, you know the proficiency of each section, and you're ready to get started on reassessments. So just a reminder for the rest of the hour, this is what you should be doing. The reassessment ticket should be completed first, indicating the standards you want to reassess. If you have pages to complete in the study guide, you need to do that. If it's an activity that you missed, again, talk to a partner. You can fill that in with that, or you can sign up for Flex to do it. And then lastly, complete any reassessments you want to do. Again, these are located in the folder in the back of the room by the lab door. Make sure you're looking in the Physics A section, the Scientific Destiny folder. There's only 2 reassessment forms this time, so pick the one that you want or both. For this particular test, since I'm not here, I'm not going to require that you check the front side with me if you don't want to, although you definitely can. You can kind of wait for me to get back, for me to check that if you want to, or you can email me kind of a picture of the front side, and I'd be happy to get back to you as quickly as I can. Regardless, if you finish a reassessment, please turn it in the bin by the lab door. If you start a reassessment today but aren't able to finish it, please keep it. You can finish it at home, you can finish it in class or in Flex or whenever. And I believe that is all I have for you guys. Thanks so much for your behavior and being good for the sub. I hope to see you soon.